All right, mathletes, let's go ahead and start section 5.4, and now we're going to get into logarithms. So logarithms, these are really kind of fun. And a lot of times when students encounter these, they're just like, oh my gosh, what is happening? What is going on? These are so difficult. I hate these things. And it's really kind of sad to me because they are kind of fun and they are really kind of neat. So it all, to me, it just kind of depends on how you teach it. And I have seen some crazy explanations out there that make these things incredibly difficult when they don't have to be. So hopefully, if you've had a bad experience with these in the past, hopefully we can fix that with this. Okay, so let's go ahead and define it. So a logarithm is defined as y equals log, and then there's a subscript down here. This is called the base of the logarithm. So it's log base b of x. So there's going to be like a little number here and then a big number here. So this x, that is not the exponent of that little b. So don't read it as b to the x. They're not connected that way. So what the heck is a logarithm? Well, a logarithm, or logarithms, are the inverse of exponential functions. So remember earlier when we were talking about inverse functions, I said that every operation has to have a way to go backwards. Well, this is the way to go backwards from the exponential functions. So exponential functions, what you do, you plug a number into the exponent, and then it gives you a result. Well, the inverse of that, the logarithms, is like you're taking the result and you plug it into the log, and it gives you the original exponent back. So let's kind of take a look at that. So if y equals log base b of x, then b to the y, so that same base raised to the y, is equal to x. So this is how you actually can convert from logarithmic form to exponential and vice versa. So what is this really telling us? Well, what it's telling us is that logs are really exponents. Because look, if you plugged in an exponent into here, like a number in for the y, you could calculate this out and it would give you a result. Well, if you take that result, plug it into the log, it gives you that original exponent back. So that's all a logarithm really is. So if you can kind of think about it in that form, it makes these things a lot easier to deal with. So there's one special one because we had a natural exponential function, the e to the x. So the inverse of it is defined as y equals ln of x. And the natural log, when you see that, that's like saying log base e of x. So they just wanted a shorthand when it was a base of e. Okay, so example 1. Find the exact value without using a calculator. So yes, you will have to be able to evaluate these things without a calculator, but they're not usually too tricky to do, most of them. So let's look at this. Log base 5 of 25. So all you're really doing is you're looking at that little tiny base number and going, okay, what exponent do I need to put on this to give me that number, that 25? So 5 to the what equals 25? Well, that would have to be a 2. So 5 squared, that is your 25. And so that's how you can evaluate almost every single one of these logarithms, as long as it's not kind of tricky. And we'll get into those, so don't worry. The other way to look at it too, if you don't like to think of it in that way, if it's a little bit complicated, you can always set it equal to x and then change it around to exponential form. And for some people, that's just an easier form to deal with. So to do it, just take the base, The variable over here, the x, is the exponent, and then it equals whatever this number is, the 25. And so again, that's going to be equal to, which is what we got earlier. So either way you go, it's not gonna fail you. Okay, let's look at this next one. Log base 4 of 64. So what exponent does the 4 need to give me a 64? Needs a 3. All right, and that's pretty much how I'm going to do most of these, is just trying to figure out what exponent I need, except for a couple of the trickier ones. Okay, so log of 100. Now this one's interesting. Some of you might be noticing, hey, there's no base number. Well, if there's no base number, it's taken for granted that the base is actually a 10. Just like a square root, doesn't have that little index of a 2. It's just invisible. So logarithm, if there's no base number there, it's automatically a base of 10. So what exponent does the 10 need to make 100? A 2. Okay, moving on for part D, log base 3 of 81. So what exponent does the 3 need to give me an 81? Well, that would have to be a 4. All right, so that's pretty much how you can evaluate most of these logs. In the next video, we'll do the rest of these examples so you can see what to do when they're a little bit trickier, not as straightforward.